Hi, my name is Mansi, and I'm presenting my Lean Six Sigma Sandwich Shop project. And I will be making some recommendations to stabilize the operations of the restaurant. Even though the restaurant holds strategic value because it's located in a large city in a downtown area, it seems to be not doing very well. And there is a rapid turnaround, which is causing a poor reputation and may impact the opportunity for the restaurant to open other sites or growth. The core problem that has been shortlisted is that there is 10% of the sandwiches that are receiving complaints, and which is leading to scrapping of those 10% of sandwiches. So I have created a goal for myself, which is measurable and achievable, which is to reduce Lean Sandwich Shop scrap rate from 10% to 2% in 3 months, resulting in $96,000 of annualized cost savings. How I have achieved that is by measuring the cost of poor quality, which is documented over here. Right now, the failure or the scraps are causing $120K in dollars amount to be lost. And with my proposed goal, which is reducing it to 2% in coming 3 months, from 10%, which is a 80% reduction in the scrap rate, will lead to a $96,000 of saving. So once we have defined our problem and goal, that is measurable and achievable, and we have eliminated the assumptions and constraint, we will focus on voice of customer. That is, what are the primary complaints we have for the business. Voice of customer matrix is a helpful tool to document customer priorities and measure them against different aspects of the business. So what you're seeing over here is for if the order needs to be delivered in 10 minutes and that's the requirement or the need, what are the drivers that are affecting that need that the customer has asked or is required by the customer. And then the metrics that governs those drivers are documented. A critical to quality tree gives us a good visual aid for us to understand what's going on. It is another example of critical to quality tree for quality and scrap. Improve quality is what the customer or as business wants, and what are the drivers for that improved quality, or for reducing scrap, what are the drivers for that, and then we can come up with the metrics for those. So once we have drawn a critical to quality tree, which breaks down customer requirements into drivers for the requirements and the units that are used to measure those drivers. Once all of this is done, we can do a risk analysis, which is probability of occurrence, how much that particular risk or issue is affecting the business, and the detection difficulty for that risk. And once we multiply all those three components, we get the priority rating for how important that particular issue is for the business. So in this slide, you can see the top 3 ones are incorrect vegetables and toppings applied, ingredients do not meet quality standards, and sandwiches are cold when they're delivered, from 27 to 18 range. Once we have done all the risk analysis and come up with a goal, maybe come up with a project charter, get all the approvals, it's recommended to draw a detailed process map, or even a SIPOC diagram is an important tool that can be used. Here is a complete process map of the Lean Six Sigma Sandwich Shop. In the middle, you can see the sandwich building process right here, and then the suppliers until the sandwiches reaches to the customers. So the total lead time for this process to start from supplier to customer is around 5.03 days. A detailed process map really helps us visualize what's going on with the business. Again, the value stream map over here, I have documented that according to the task. There are 7 tasks to create the sandwich. And here are the timings for the task and the number of employees set up to perform those activities or processes, and the cycle time is calculated by the number of employees and the time to do that task. So here's the cycle time that's calculated. This slide tells you the process map that I discussed in the previous slide, task 1 to 7. Here are the documented time for those tasks. You can see the cycle time, the process cycle time varies from all the way from 15 seconds, which is task 2, to all the way to around 90 seconds. And there is a lot of variability in this process map. I would like to see it distributed, the tasks to be distributed evenly according to the cycle time if possible. Here, throughput per hour is 600 divided by 12 employees working for 10 hours a day is around 5. And the takt time is basically calculated to 60. Takt time is time over demand. Moving to the last line, I have revised the work balance table. On the left, you can see the table that I've discussed before, which has a lot of variability from task 1 to 7. How I have redesigned the new work balance table is that task 1, which is over here at 120 seconds. I have kept it the same way, and I have combined task 2 and task 3, which is 105 seconds of total, which is coming for a cycle time of 52.50 with 2 employees. And then the next task, which is receive, order, and select bread, which is 1 employee and 15 seconds. And then task 3, which is add protein to sandwich, and 1 employee, which is 90 seconds. Task 4, which is add vegetables and toppings, 2 employees and 120 seconds. And task 5, which is employee place sandwich in the toaster. I've combined task 6 and 7 to a task of 90 seconds, which is task 4 over here, with a cycle time of 45 seconds. By redesigning my work balance table, I have reduced the variability that we were seeing earlier for the process map. And now we have also reduced our task cycle time to 480. And if we calculate the number of employees that we need for this task time, which is 480, is around 8 employees. Once I've done that, I've done a Pareto analysis. Pareto analysis is basically a chart that will tell you the probability of the defects over here. That's what I'm looking at. So as you can see, from cold sandwich to wrong dressing, around 53.8% of the defects are coming from cold sandwiches and wrong dressings. And this is what I'm going to be focusing on. Once all of that are governed, I have redesigned my line in U shape, record and deliver orders starting from the top right and moving to receive and then add protein to the sandwich, which is having 2 employees, and then moving to station 3, which is having 3 employees, which is add vegetables to sandwich and place sandwich in the toaster. And then station 4 is a deliver sandwich and a wrap, which I have set up as a ratchet style. And also I have recommended employees, around 10 employees, which has come to a throughput of 6, which was earlier 5 with 12 employees. Now, once we've calculated that, how I'm going to monitor my risks is by improve and record and order delivery through my 555 audits, and ingredients do not meet quality standards, I will be sampling them, and I'll be doing a 555 audit on that as well. Sandwiches cold when delivered. I'd be providing heat lamp so that if during rush hour, the sandwiches are waiting for delivery, they can be stored under the heat lamp to reduce the customer complaints. I have again shown you my cell primarily divided into 1, 2, 3, and 4 stations where the raw material enters from one end and then the final product exits from the other end. And this is where I'm incorporating my heat lamps and where I'm doing my 555 audits. So by doing and following all these suggestions and recommendations that I've made, like I've shown you earlier in presentation, that we were having an annual sandwiches that are annually made around 218, 400. That was our number, and then the throughput was around 5, which was causing the labor hours to around 43,000. And the new throughput that I have created by balancing the process map or the cycle time is 6, and the labor hours needed annually with this new throughput is around 36,400. My expected annualized labor saving will be around 109,200. Expected saving by reducing to scrap to 2% is approximately 96,000. And then the operations, the cost of operations of buying a heat lamp I've added to around 6,000, which will lead to a total expected saving of around 200,000, which is 199,200. So this is my proposed suggestions. Thanks for your time and listening. Hope you like my presentation. Thank you.